Thank you guys for all coming. So shall we begin? So, of course, legal disclaimer, these words and representations are my own, not my previous, current, or future employers at any time. You know, I have creative ideas, and that should not reflect upon others and other ideals. Once again, you guys are all awesome, especially if you're scooching down, making room for everyone. Thank you. You know, it's great to always hear. I always have this little personal rule for myself where there are more than 10 people who show up, I am ecstatic. So I'm overly ecstatic and overjoyed, and I'm going to celebrate heavily after this talk. So what we're covering today is backdooring Git. We'll go more into what is Git. You know, we'll talk about how to backdoor it, how to prevent backdoors, you know, for the white hats, for the black hats. Here are a few techniques which did work or did not work based on your perspective. But you might imagine we're not going to cover the entire SDLC or how to distribute and create beautiful, elegant code with integrity and security. Now, I don't care how you guys publish it, how you guys build it and do your chains of integrity. Meh. It's more of how does the beautiful, elegant code get into that repository and how does it leave it. As you might imagine, I'm not going to be talking about the myriad of source control management tools and technologies out there, i.e. SCMs. There's so many out there from the dawn of computer science to new tools being created daily to scratch a developer's itch. Some proprietary, certainly, many open source. Now, another thing that we should kind of clarify in the beginning is what is a backdoor versus functionality? So for instance, here we have an OpenBSD political shitstorm that happened a long time ago where this person alleges, you know, hey, my NDA with the FBI came up. I just wanted to let you know the FBI and other entities paid for us to introduce backdoors into some functionality for site-to-site VPN and other technology. And mind you, this was an allegation. By the way, you should check these entities who, you know, committed all these changes and verify that they didn't introduce anything. So some people might view this as a backdoor. Others might view it as works as implemented or functionality. So I'm not going to get into that debate. Let's just all agree backdoors are evil. People can still write horrible, ugly, error-prone code, and that's not good either. Now, hopefully there are none of us in the audience here who think, yeah, I don't need source code management. You know, I'll just eat myself some diffs, you know, pass around friends. If that's the case, this talk's probably not for you. In fact, you'll probably get pretty bored along the way. But to kind of set the stage, let's start at the beginning. Unfortunately, I'm not going to be able to help you pick which SCM tool that you should use. Maybe if you pray to God or Tom Cruise, he might be able to tell you. But I'm not going to hear and tell you which one's better than other. Some people love to say SVN is CVS done right. I'm not going to harp on a lot of those myths or items. But there certainly is something called revision control. There's something called source code change management. And they are very different from each other. You wouldn't think so. Like, imagine if you were to have a large amount of documents and you wanted to say, hey, I have a new pen test report, I'm going to increment the version and, you know, use Git or some source control software. It will break horribly or vice versa. You'll go through a lot of pain and suffering. Or if you want to use binary files, a lot of the algorithms and techniques used by these tools don't like or appreciate binary, so it'll be very ugly. Images, things like that, or hell, even movies are extremely large objects. They'll just choke and die. So, as I kind of love to say to myself, with developers, you know, as soon as you pick up a hammer, you know, everything's a nail. Well, here we see Jeremy Clarkson, that same mentality of, hey, I have this cool, nifty little tool that demines fields, and hey, let me use it to take down a house. Because not only would that work, you know, great for entertainment, but you know, that looks like a nail.
Firing up the rotors. Oh God! Why didn't we have this in Albania? Goodbye, laboratory.
Bricks fly everywhere.
This is bloody brilliant.
Stop there! Stop there! Jeremy, the roof's going to land on it.
This was no problem because my destroyer of worlds had a special...
special fun little feature called a remote, which later on he goes in there and hilarity ensues for everyone's comedic benefit. But as you might imagine, the proper hammer for, say, taking down a house might be explosives, such as what we see here. So once again, really find the tool and the SCM that really works for your workflows and processes. Because when you think about it, you pretty much have two fundamental gaps. You either have the traditional model where there's one source of truth everyone interacts with and not with each other. And you have more of a distributive model where everyone can interact with each other and there is no authoritative source between each other. And if we look over the history of SCM tools, say, hey, Google Trends, tell me what's popular, what's not, what we see is Git since 2007, just rising far above and beyond. SVN here peaks around 2007, then just kind of dribbles down. Sure, Perforce and others, still stay low, and CVS just dies slowly. But it's interesting because Git seems to be the hot, cool new thing. I hear about it all the time, like, hey, what about Git? Not so much Mercurial anymore. And since we're here to talk about Git, let me transition into there. So the problem that I had from the very get-go is, what is Git? Well, it pretty much came down to two fundamental moods. If you're happy with Git, it's called the Global Information Tracker. But Git does break, or the processes may break, or you may just destroy your tree. And in case that happens, you think it's a goddamn idiot truckload of shit. And I mean, people are furious. I mean, just ignoring the security consequences, think about the functionality. Hey, you can't use your repo, all of your magic cancer cure, the recipe that's in there, everything that's in there, it's broken, you can't access it. So imagine someone who probably gets very furious, there's a very popular internet meme about it. Think about how Hitler feels when Git breaks on him.
Dem Feind gelungen, die Front in breiter Formation zu durchbrechen. Im Süden hat der Gegner Zossen genommen und stößt auf Stahnsdorf vor. Der Feind operiert jetzt am nördlichen Stadtrand zwischen Frohnau und Pankow, und im Osten ist der Feind bis zur Linie Lichtenberg, Karlshorst gelangt.
Mit dem Angriff Steiners wird das alles in Ordnung kommen.
Mein Führer, Steiner konnte nicht genügend Kräfte für einen Angriff massieren. Der Angriff Steiner ist nicht erfolgt.
Es bleiben im Raum Keitel, Jodl, Krebs und Burgdorf.
Das war ein Befehl! Der Angriff Steiners war ein Befehl! Wer sind Sie, dass Sie es wagen, sich meinen Befehl zu widersetzen? Oh, weit ist das also der Fall. Das Militär hat mich belogen! Jeder hat mich belogen, sogar die SS! Die gesamte Generalität ist nichts weiter als ein Haufen niederträchtiger, treuloser Feiglinge!
Mein Führer, ich kann nicht zulassen, dass die Soldaten, die für Sie verbringen...
Nicht als Feiglinge! Verreiter, Versager!
Mein Führer, was Sie da sagen, ist ungeheuerlich!
Die Generalität ist der Geschmeiß des deutschen Volkes! Sie ist ohne Ehre! Sie nennen sich Generale, weil Sie Jahre auf Militärakademien zugebracht haben, nur um zu lernen, wie man Messer und Gabel hält! Jahrelang hat das Militär meine Aktionen nur behindert! Es hat mir jeden nur als Widerstand in den Weg gelegt! Ich hätte gut daran getan, von Jahren alle höheren Offiziere liquidieren zu lassen, wie Stalin! Ich war nie auf einer Akademie. Und doch habe ich allein auf mich gestellt, ganz Europa erobert. Verräter! Von allem Anfang an bin ich so verraten und betrogen worden. Es wurde ein ungeheurer Verrat geübt am deutschen Volke. Aber alle diese Verräter werden bezahlen. Mit ihrem eigenen Blut werden sie bezahlen. Sie werden das saufen in ihrem eigenen Blut.
bitte gerne. Jetzt beruhig dich doch.
Meine Befehle sind in den Wind gesprochen. Es ist unmöglich, unter diesen Umständen zu führen. Es ist aus.
So imagine if you're that mad that functionally it's functionally broken. Wait until someone hacks your repository or is able to introduce unauthorized code. I don't want to imagine how people would react to that. So the interesting part about Git, it's not your traditional system. It's very distributive in nature. People can work with each other. You don't have to continually have access to the source of truth. I could work with, say, Chen Kai, and Chen Kai would work with Alice and Bob, and I could transitively interact with Alice and Bob through Chen Kai. It's a very powerful technology that allows processes to kind of be warped around it instead of always having to have access, say, to the main repository and, I can't do any work unless I'm online. It's a pretty nifty thing. But the interesting part about the distributive nature is that there's this ring of trust where now you are forced to trust someone and the decisions that they will make, and that the decisions of people that they trust will make, and transitively goes down. But the interesting part is when you think about it, to quote, if you've ever done any security work and it did not involve the concept of network of trust, it was not security work. It was shit. I don't know what you were doing, but trust me, it is the only way you can do security. It's the only way you can do development. Mind you, this is only one perspective, but it's a rather influential perspective. So can anyone here tell me who said this? And to help entice you guys, here's a party invite badge for the DC 503 party. Who said that back there? Come on down. Yeah, so Linus Torvald ended up saying this. He has some pretty choice quotes. He's pretty, how would you say, blunt. Thank you, sir. Because the interesting part is you fundamentally end up with this graph of trust where you're at the center of it, and then you have all these people who trust each other. Some people trust others. You end up with this ugly graph. So you end up seeing this commit or this code from someone, and you're like, what? Where did this come in? Like, I don't get it. Should I trust them? And we'll get a little bit to that later. But it's very important to understand this because you end up with another interesting choice quote where since you don't want everybody to write to the central repository because most people are morons, you create a class of people who are essentially not morons. And most of the time when that happens is that you unfortunately make these non-moronic people too small because it's really hard to know if a person is smart or not. And even if you make it too small, you will have problems. So this whole commit access issue of who's allowed to push to the source of truth or who has authority at any one time, yeah, go ahead and ignore it. Separation of privileges, things like that. Yeah, just give everyone commit access. It's unfortunately a huge psychological barrier where no one trusts me, or also cause endless hours of politics, and especially in the open source community. So can anyone, once again, tell me who said this for yet another DC? Yes, correct. Linus Torvalds, as you might imagine. Once again, very blunt. One of the thought leaders behind Git itself, and he has some interesting design decisions within Git. We'll see which benefits security as well, but also the morons and the error-prone code kind of pruned out. Because the interesting part is when you end up typically using a Git repository, in a more mature fashion, you'll end up with this blessed source of truth that everyone can pull from, developers, QA, and others, but they are only able to push to their lieutenants or dev leads. The dev leads or whoever else will go through checks and balances, code reviews. Probably reality is being deadline driven. They'll just quick look at it, code review, checkbox done, done in 2 seconds. And then eventually they might push it to the dictator, be it release or some other higher authoritative source that says, yep, everything looks fine, we're either ready to push it or push it back into mainline. So go ahead, dictator, they have the ability. So the interesting part is this introduces the opportunity for backdoors, inadvertent or not, because it's interesting. Some people will think, well, it's not my job, I'll let someone else do it. And it's quite fun, because when I started to look for where have people backdoored repositories, just let's ignore Git over the history, unfortunately there's not a lot of data out there, at least in the public domain. I'm sure in commercially there is, but in the public domain, there isn't a lot. Back in 2003, anyone may remember this fun little Linux backdoor someone tried to introduce. It wasn't in the main repository servers for Linux, but a CVS server they had off to the side for people who want to use CVS. And as we see here in green, it may be hard to read, but if option, some value, UID 0, then return some value. Okay, that doesn't mean much to anyone who just looks at it. You're like, okay, what the hell does that mean? Well, what this code would introduce is if your program ran on Linux and they had the appropriate flags, it would have administrator or i.e. root privileges, just by a matter of fact of running. So it could modify critical system files, it could add or remove users. It was effectively God. Oops. Now the interesting part is when we look at the change history, kind of starting here at the bottom, it's hard to see, Torvalds, fix the zombie, raised with self-repeating threads. Then the next message up is empty. That's odd. Another empty one. And another empty one from the same guy. And then later on he says, oops, I worked with the wrong file, fixed again, said Dave. Well, hey Dave, what the hell happened? This is not legit. Dave swears up and down that it wasn't him. So if anyone can help forward and claim responsibility, that would be nice. So if you end up following this thread through the mailing list, you'll end up realizing, whoa guys, someone just tried to introduce a backdoor through our CVS server, which isn't how the workflow would work. It's kind of odd, but maybe someone would eventually propagate. Let's take care of this before it blows out of proportion and the media catches on. And they're like, too late, Slashdot already got it. And then it blew out. So fast forward along, let's look at all these cloud repositories, GitHub, Bitbucket, others. The interesting part about these technologies is that they're being built with newer technologies, newer techniques that necessarily may not be battle proven or battle hardened. As they build it with Rails, they said, your data will be safe. Well, some of you guys in this room might remember this fun little hack where they didn't necessarily hack GitHub itself per se, but Hormanikov had this interesting vulnerability in Rails that he discovered where he could change attributes. And he went to the Rails community and he said, hey guys, here's a pretty nasty default behavior, you should change it. And they're like, no guys, really, you should change it. It's like, okay, I know how to show them. Not having the best social skills possible, as you might imagine. Decides, hey, I'm going to go to GitHub, they run Rails, I'm going to exploit this vulnerability on their service and take over some keys that allow me to push a change and then push to mainline saying, hey guys, look, see, I can do this. It's vulnerable. So all he really did was, hey, let's give me some special users who have some privileges to be able to modify that repository and say, hey, give me that key. And then he pushed it and they're like, whoa, okay. And then Rails community decided to accept that and said, okay, quick, push out a fix and so on. And there was some blowback. Plenty of stuff online if you want to read more about that. So, story time. Sit back, take a drink, kind of settle in, and I'm going to tell you guys a fun story. So imagine my manager comes over to me and says, hey John, your TPS reports, do you have those done yet? I'm like, no, it's a waste of time. I don't know why you'd even want me to do it. I'm just gonna, can you not do my job and you'll end up promoting me anyway, so thanks. He's like, yeah, but I'd love to promote you, but you introduced a pretty nasty buffer vulnerability in your simple calculator program. And I'm like, no, I didn't. I actually don't hate my job that much. Well, let's take a look. Open a calculator, and then you see a subfunc call that calls car. Yeah, that's a vulnerability. Okay, let's look at the log. Yep, introduced by me, calculator C, simple program. Okay, sure. Finish time traveling. Wait, what? Steve Jobs at steve@apple.com? That's not right. That was June 27, 2015. June 27th, 2008. Wait, what? Time traveling like it was cool? from beyond the grave? Wait, what? That wasn't me. And they're like, no, well, you committed it. You accepted it. That was you. No. So maybe it was my friends who decided to pull a prank on me. Maybe it was my coworkers. Or maybe it was the evil hacker with their ski mask, standing behind my computer. So, the security team, more likely probably product security team, will come over and say, hey, John, let's figure this out. Keep calm. We're here to help you. So since you're using Git, who do you trust? Who are you set up to inherently trust? And I'm like, everyone? This funny little saying, in God we trust, all others must submit an X.509 certificate. Okay. But Git has this really nifty feature to really handle that trust, to handle that integrity. So they're like, hey guys, let's use crypto, because encryption solves everything. So they end up adopting the GPG trust model. Now, it's kind of complex to explain, but effectively you can somewhat trust someone, you can fully trust someone, you can recognize someone, or you can just absolutely not trust them. And you can apply that down to the children. So let's say I trust Chen Kai fully, and I'm going to trust everyone he trusts. Then by default, I'll trust everything there. Well, say I have this person called Alexandra, and I don't really trust her or the decisions that she'll make. So I'm not going to trust or sign anything or accept any signature. So, Well, there's some that I kind of trust, but I want to verify and do some additional due diligence before I do anything. And this goes on and on and on and on. But effectively, it's all based on the GPG model. So, hey, you want to build a PKI infrastructure? Go for it. But ultimately, within Git, you're a one-man army when it comes time to commit. You only get one signature. You can't have two people both sign it to say, yes, we both agree that this is all right or works as designed. And that these signatures are embedded. Like here we see Jake with Nuth, with their fun little recursive meme. And these signatures can be embedded in the repository, or you can kind of extract them and do other controls around that, which will learn a story for another time. But by default, they will be in the repository. But you end up with pretty much 4 fundamental ways that you can sign this statement, this assurance. You can sign every single commit that you're going to change. And you say, yes, I authorize this. It's very easy to pick out the things that you like, and you can say, yes, I reviewed each and every one. But unfortunately, it is a hassle. Sure, 5, sure, but when I'm dealing with 100, a few 100,000 lines of code because Red Hat, released a new minor version for their kernel, oh God, that is a hassle. So what you can say instead is, yeah, I'm only going to sign the merge. I don't know everything else, but I'll sign it. It's quick and dirty, but you'll still have police coming at you for saying, hey, introduce a backdoor. Your manager may come over to bother you more about TPS reports. Or you can just flatten all the changes that you're about ready to look at and say, meh, give me all the changes, and I am just going to say I did it all and throw it in there. But the problem with that is you lose the history of how all of that code before you was generated. And if you try to bisect or pull it out, oh God, it's kind of ugly. Or you can do a version that doesn't scale at all. So imagine we have 2 people here where it's like, hey, this is me, and I did this. Here's a picture of my hash. You'll see Google engineers use this from time to time when their Git repositories don't work. See it post up on more Google Plus. They love to do this. Be like, yeah, this is me. See, look, my Google Plus identity, and this is it. Yeah, it was me. As you might imagine, that doesn't really work. But the interesting part is if you decide to destroy the history, well, history is written by the victors. So if you want to do the flattening commit and not have a history, go for it. But if you actually really care about the history, but you want to live on the wild side, you want to take a chance, yeah, go ahead, just sign the merge commit. Or if you want to sign every single commit, that's technically the most secure from an integrity perspective. But I don't know about you, but I'll be lazy and probably automate it and just be like, yeah, all these look good, go ahead and automatically sign all of them. So you want to prevent that, to actually give some assurance that, hey, I actually did review this. But once again, danger zone. Because what does it mean to actually sign? Like, is this a beautiful lady, or is this a very not beautiful lady? So what does that mean when you sign? This snapshot and commit message was authored as described in this commit's metadata, such as, hey, Tracer T at YouTube, had this fun little backdoor? Or does it also mean that, hey, the snapshot and commit message were authored as described, and all of the parents, the things that led up to that, are also legit? Or do you also want to say, hey, here's the diff, and yeah, everything's fine? Because as we see here, someone has modified the sudoers file, said, hey, yeah, evil hacker user, give them all privileges and passwordless sudo. Because it's hard to run fast and loose when you continually have to enter in a password. But don't worry, as we see in the metadata, security said it was okay. So it must be authorized. Now once again, I'm still trying to figure out, okay, how did they hack me? How did they take over and introduce that simple defect? Well, one thing that I personally love to do to others, especially at work, is, hey, I noticed you left your computer unlocked. I also like to live dangerously too. Sometimes I'll change their background to My Little Ponies, or in this case, a Nicolas Cage theme experience, to make them really feel at home. Or in actually this case, what one could do is just pull up their IDE, because they probably don't want to enter in their credentials each and every time they commit or push something. Just go ahead and open it up, put your little backdoor, and just go ahead and try to push it and see what happens. Hey, you never know. Now, the script kiddie way to hack Git is very well known. It's not even fair to call this a hack, but you can actually change your email and username. So you just say, hey, global, my email address is X, my name is Y, and just operate that way. And as far as the repository is concerned, that email address and username is that. You didn't have to prove that you owned that email address. You didn't have to prove you were that identity. So it leads to some interesting behaviors. In this case here, we see just simple evil backdoor, our Tracer T guy from YouTube, Lead Hacker 101, creates some stuff, and then suddenly changes over to DT at DT.com. Once again, just this is a behavior, so you really can't take anything that you see in a repository if you're really concerned about who created it or the authenticity of that just based on email and name alone, hence signing. Or maybe the hacker team let loose a new exploit, or someone found it from the leaked repository and then compromised your computer, waited till you walked away, and then worked within the system. But when you think of it from that perspective, it doesn't matter which tool you're using. You have to rely on other IT controls or other mechanisms to really lock that down. There's nothing inherent that will protect you from that. But the interesting part is the integrity of a commit and other identities is a SHA-1 hash. They do a little bit more than that, but effectively, you need to find a SHA-1 collision to introduce your own malicious backdoor or to obliterate something else previously. So imagine if I were to send you up to the moon, free of charge, of course. I would have you search through every single atom of the moon and compare them and let me know when you find two that are exactly the same. That is how likely you will find a hash collision. Or another way of putting it, I love this book, is a higher probability exists that every member of your programming team will be attacked and killed by wolves, completely unrelated, all in the same night. So if your tinfoil hat is really, really tight and you're really worried about everyone getting killed all at the same time by wolves, you may want to take them out shooting, get them comfortable learning how to defend against wolves. But the interesting part about Git is it has this awesome defensive mechanism built into it by design. So let's say up here, this red liquid was my original artifact, or my original super secret configuration. And if anyone were able to modify it, it would spell doom and end of the world. So let's say someone found those two atoms that were the same, all my entire development team was killed by wolves, and here we have the red liquid coming in. Well, when Git sees it, it'll be like, oh, hey, I see this new object that you're trying to give me is the same as an old one. Yeah, I'm just going to ignore the new one. So collisions, okay, if you find it, it's going to look like gibberish. Hopefully it'll catch it there, but even then it'll ignore the new one and just continue to track the old one. So not entirely useful there. But they're actually, if you take your tinfoil hat a bit tighter, one way to actually do it is to get someone to apply a patch, and when that patch is applied, then it causes the collision. And that would work. But the reality of that happening academically is that that patch would look like gibberish. I mean, it would look like line noise, nothing sensible. So common sense would dictate that you would be like, oh, I don't even know what this is. Let's get rid of it. Ugh. So unfortunately, Git is vulnerable to prefix attacks. Brad Fitzpatrick of LiveJournal fame, and he works at Google now on interesting projects. He wrote a fun little Go script that would be like, hey, I want a prefix of DEF CON in the hash. Because, developers are kind of lazy. Maybe they didn't decide to use the full hash for comparison. They only look at the prefix because, Git's pretty useful like that. Let me introduce my own prefix, and hopefully they'll pick up my malicious commit instead of the legit prefix down below. Shouldn't take more than 5 seconds to at most maybe a minute to modify the head to get your prefix of choice, but it's a fun little script. It works. Now, the fun part is that I had looking after this is, okay, now I'm being told by my manager I need to sign all of my commits, and we're going to implement a new PKI infrastructure. We're going to do this right. Well, I decided, okay, cool, but let me get some data about that. So, hey, GitHub, you have a search API. I want to look at all of your popular projects that have over 9,000 stars. That's about 140 to 160 repositories at the time. And it's interesting. What we see here, let me get it out. Oh, awesome. So it's kind of fun. So top and to the right is good. That means a lot of commits and a lot of signed commits. I would love to, but this is called demo fail. So I'm going to try to kind of coerce and work with it. So as we see up here, top to the right, Linux is way at the top, no surprise. GitLab HQ is kind of up there, Rails, and a few other popular projects we're familiar with are up there. And then there's a few down here. Now, fortunately, because of the demo fail, you can't see, but the scale is in logarithmic scale. So as I change this to a much more linear fashion for both, you'll see that Linux is way up there. So way up here to the right, and then far down here is everyone else. So your takeaway from this is not a lot of projects out of those 140 were even signed or even had any attempt to provide the authenticity that I'm a prima donna developer and I committed this. And in those that do, they're relatively small in number, even relative to the number of commits that they had. So it's interesting when you look at that. Now, the fun part is this is DEF CON, right? And what's a talk without O-days? So, I hunted around for a few months trying to chug around. So I was like, which SCM do I really want to poke at or service and really try to find some decent O-days? And not scientific at all. Hey, let's go to National Vulnerability Database, some other vulnerabilities, and say, hey, let's put in these names and see what pops up, either for the tool or products that have that name. And Perforce only had 7. Interesting. SVN had 438. CVS had 566. Git had 2,000. That was up because it's popular. I'm not going to try to do it. Like I said, this is not scientific by any means, but okay, maybe I'll find something over there. So hey, let me take CVS and SVN through static analysis. Let me try to see if anything pops up there easily. No, it came out squeaky clean. I was like, damn it. Ugh, I was hoping to find some really old defect from the 80s or 90s. However, Git has its own challenges. Had some nullity references, had some memory leaks. It's not that great, but unfortunately, a lot of those vulnerabilities, I can't imagine how they'd be exploited, or they're so esoteric that I gave up after trying to reproduce and develop an exploit after a week. I give up and just throw my hands up in the air and say, done. However, let's look at GitLab, because there's something I can do. It's Ruby, it's Rails, let's have some fun. It had some issues in 2014. So unfortunately, I tried this food coloring. One of my coworkers brought it for me. It tastes like propane. It's hideous, so we'll just have to rely on this image. Witness me. But here's an O-Day for GitLab. Now, to execute this one is almost asinine, because somehow you would have to modify a configuration value. And if you're able to inject your malicious OS command in there, then sure, it will happily run it. No sanitization. But how about we give you guys something a little bit more useful? So how about your good old, hey, give me a file from the file system. Well, hey, Wiki, find me a file with this completely trusted parameter called ID and version. And hey, if it exists, send it to me. Sure. So imagine poor OS controls, such as improper permissions for the Rails app or OS. Yeah, give me etc password. Maybe if someone's running fast, it's not that likely. You'll probably get the walk around the file system, find improper permissions, global read, global write, things like that. So fun. Now the interesting part about this is you guys need some tools to either hack or to defend. A lot of the tools that I've curated and have put on Lord AppSec / Git backdoor are more for the defensive side, such as how to automatically, when a commit is pushed to you, to actually review it automatically, trust that it came from your authoritative source. It's kind of interesting because a lot of them rely on this concept of I'm going to trust the client. I'm going to trust, and I'm going to put this control, such as verifying all the commits and everything, on the client. Because the client will never lie to me, or the client won't disable that check. And then just more or less network of trust fail. So to kind of bring this to a close, one just doesn't oops, backdoor this stuff. Oops, I created a defect. Honestly, in all my years, I've never met a developer, QA, or anyone who ever wanted to introduce a vulnerability, whoever wanted to write error-prone code. Sure, there are probably some who had a vendetta, but honestly, they never wanted to. And Git has some pretty cool, nifty features inherently built into it, but it still relies on this trust model. And sure, you could set up a very expensive PKI infrastructure in the GPG model, but as we kind of see with GitHub, Bitbucket, and many other technologies, they kind of ignore that, and they implement their own authorization and authentication model. Is it better or worse? I'm not going to sit here and tell you, but they decided to go down a different route. So I'd like to thank you all for coming. So 2 more things. Imagine if you're this rock star Stanford professor, or you're this amazing rock star game developer. Avinash built this awesome Python module. You can say, hey, from Rockstar, import Rockstar, activity, Rockstar, and you give it a parameter such as days, and you give it a number, and then you're like, hey, make me a Rockstar. And what it will do is it will modify the current repository and make it look like as if you worked for that many days. Pretty awesome, right? So, I threw this up on GitHub. I created a few repositories that have histories going back to 1950, because, that makes sense. GitHub and a few other graphs and models and tools, Bitbucket, others couldn't handle it. Some would just only go back to life of the account. Others would go back and just say, no, I'm not giving you all of that data. But I got a funny little email recently from Roman Storm being like, dude, that's crazy. And I'm like, yeah. And there was this another interesting hack that came out recently from Ben Cox. He did an interesting way where he was able to harvest all of the SSH authentication mechanisms for GitHub, and was able to pull all those public keys and started looking at their strength. Are they weak? Are they secure? And he told GitHub, and GitHub was like, not our problem. We don't generate these keys. They're given to us by the user. We don't really have a shared responsibility. And he was like, I don't know, because when we look at the data set, you see a lot of RSA keys, with bit strength of, 256, 512, things that are already known to be just, wait, what? When were these generated? And GitHub was like, yep, we're going to quick expire all those keys and say, hey guys, you need to change it. So once again, I cannot recommend more than enough Pro Git book. It's a great source to know where to avoid pitfalls and common things like that. But thank you guys for coming, and that truly is all.